we're going to factor the quadratics. The way we factor this quadratic is we make a little x thingy. You put the last number on top, you put the middle number on bottom. Now, from here, you're trying to find two numbers that multiply to get 24, and the same two numbers add to get negative 10. So two numbers that multiply to get 24 and add to get negative 10. In this situation, it's kind of like a guessing game. You kind of got to go through all your multiples. In this situation, it's negative 6 and negative 4. Now, if you didn't see that, what you do technically is you go to 24 and you think of all the numbers to get 24. 24 times 1. Then maybe 2 times 12. And then 3 times 8. And then 4 times 6. And out of all these ways of getting 24 multiplying, you have to look which one, when you add or subtract them, gets negative 10. Remember, you have integers. And in this situation, 6 and 4 gave us negative 10 and multiply to get 24. Most of the time, you're not going to sit here and write all these out, but writing all these out can help some people. You got to write down all the ways to multiply it. Now, what did all that mean and do? Well, this is called factoring. This is factored form. Your answer is x minus 6, x minus 4. That is your answer. Now, what the heck did I do? See the negative 6? See the negative 4? Put an x in front. Again, what does all this mean? If I was to FOIL this, I would get this answer. And from here to here, it's called factoring. Again, if I was to FOIL, you'd get this. Okay, that was an easy type of problem. Now we're going to do problems where you actually have a number in front, and this number in front complicates the thing. What you're going to do is you're going to take that 2 and the 15, multiply them, and get 30. Still put the negative 11 on bottom. I want to figure out what two numbers now multiply to get 30 and add to get negative 11. In this situation, it's negative 6 and negative 5. So we keep going. Then x minus 6, the x minus 5. But there is a step that is not done, and a lot of you will stop right there. Because we took this 2 right here, and we multiplied it in, you technically have to get rid of it. You brought it in to help you, but now you have to get rid of it, so you go down here and you divide it back out. When I divide that back out, reduce. 6 divided by 3, 6 divided by 2 is 3. 5 over 2 does not reduce, so you take this 2 and bring it up. So that's 2x minus 5. Again, reduce if you can. If you cannot reduce, bring it up. Now, if you can reduce, reduce it, but if it still stays a fraction, you still bring it up. But in this case, situation, that does not reduce, so you bring the bottom of the fraction up. Some people call it bottoms up. The reason? You take the bottom pieces and move them up. When do you do this division bottoms up thing? Whenever there's a number in front. If there's ever a coefficient on the x squared, you have to divide it back out at the end. Okay, number 3. You probably don't want to multiply 9 times 25. You're going to get a really big number. You could do this process here for number 3. But this is actually something called a perfect square trinomial. And I want to show you a shortcut to certain types of problems. This one, if you look at these two pieces, are both squares. This is 3x squared, and this is 5 squared. Okay. If you get a trinomial where this is squared and this is squared, you want to check something because it will make your factoring a lot easier. What you do is you take these two things and you're going to multiply them. You're going to take 3x multiply by 5. So you get 3x, multiply it by 5, and then double it. You take the 3 times the 5 and double it. What do you get in this situation? 30x. Now, ignoring the negative for now, does that match the middle? Yes. If when you take these two values, multiply them and double it, if that value is what's in the middle, your answer is simply this, 3x, that 5, and since that's a negative, it's minus squared. It's a really simple factoring if you can notice these are both squares. If those pieces are multiplied and doubled equal the middle, then it's simply that piece, and whatever sign that is goes in the middle, squared. It's a very quick factoring technique. You don't need to know this factoring technique, but it makes life a lot easier if it's a perfect square trinomial. It's called a perfect square trinomial. Because it's squares and it's trinomial with 3 terms. What does 3x minus 5 squared mean? It means 3x minus 5, 3x minus 5. That's why I put the square. It's just a shortcut. It's a useful shortcut. Last one, number 4 over here. You could do this. Put negative 81 on top. And how many x's do I have? 0. From there, you can maybe tell that would be a negative 9 and a positive 9. So the answer is x minus 9, x plus 9. So in this situation, negative 81 and 0, what are my two sides? That is a possibility. But there is a shortcut. Just like on 3, there's a shortcut to this. That in the long run, you're going to want to learn. Here's the shortcut. It's called a difference of squares. And what I mean by that is, see right here, do you see I have x squared minus 9 squared? Kind of like here, I have 3x squared and 5 squared. Now, if you have a difference of squares, see that's both squares and there's a difference, means minus. If you have a difference of squares, do you see x minus 9, x plus 9? You just take those two values, make one a minus, one a plus. That's the easiest way to do difference of squares. Notice there are squares. Simply take the pieces that are squared, put one a plus, one a minus. It's real simple. You don't have to do this x thingy. It's very similar to this one, except this one you had to multiply double it to check the middle. But they're kind of similar, but they're still different. This one, don't forget to divide out the GCF, not the GCF, the coefficient. And these, be happy, they're easy. Just make sure you can learn how to do these x things. People call them diamonds, but